So with Pythagorean Theorem, you have a triangle that's ABC. And what did we say our formula was? A squared plus B squared equals C squared. Okay? So what you're trying to do right now is to prove that the square of A that we just cut plus the square of B is the same or is congruent to C squared. So right now try to rearrange this on top of C so that you can prove that they are equal. So you're not just taking my word for it. The leg that is across from the right angle, see how it's across from the right angle? This is called the hypotenuse. It's across from the right angle. Across from the right angle, yes, it should be glued in your notes. Okay? Now, the two that are adjacent, who remembers what adjacent means? Next to each other, okay? These guys right here, A and B, these are adjacent, and they also make a 90-degree angle. Or an L, okay? They make an L, and they're called legs. L is for legs. Okay? So, sometimes you don't have a picture, and you have to know this. So, make sure that you know legs are what make the 90-degree angle. And the hypotenuse is the one that's across from the right angle. This is the Pythagorean Theorem. A squared plus B squared equals C squared. Okay? Now, remember we talked about the opposite operations in algebra. What were the opposite operations? Okay, multiply and divide. Add and subtract. Okay, well, x squared, the opposite is going to be square root. Okay, so that's why your warm-up was about squares and square roots. So you're going to be doing the opposite of x squared sometimes. Sometimes you're going to be doing the opposite of square root. Okay, so you need to remember this. Does anyone know what this little guy is called? Square root. It's called a square root, but it's called a radical. It's a radical sign because today on our assignment it's going to say if your answer is not a perfect square to leave it in radical form. So that just means to leave it as the square root form. You don't have to actually solve for it. Okay? Sound pretty easy? Okay, let's look at a couple of examples. So draw a right triangle. What does right triangle mean? Right angle. Yeah, it has a right angle. Now how many degrees are in the triangle? 180. Yeah. And this guy is 90. Okay? I want you to label one of your legs. Okay? It doesn't really matter which leg. I want you to label one of your legs 6. Label the other one 8. And label your hypotenuse C. Okay? And we are solving for our hypotenuse. Every single time you have to write the formula. A squared plus B squared equals C squared. Okay? Every time you have to write the formula. Especially because tomorrow we're going to be going backwards. After you write the formula, our next step is going to be what? What do you think we usually do after we write a formula? Plug it in. Solve for the variables. Okay, so A, does it really matter which leg is which leg? No, because when you're adding the same number, like 2 plus 3, 3 plus 2, what property is that? Do y'all remember? Where could you look? Journal. Somebody tell me what property that is real quick. What property is it where if I add the number, the order doesn't matter? We glued in this nice yellow paper. Mine is on page 8. I don't know what yours is, but we glued in the properties.
I have 8 too.
Okay, is it the associative or is it the commutative?
Commutative.
Commutative, okay? So it doesn't really matter when you're adding which number you pick. Now, my first thing I'm going to put is A. So I'm going to put 6 squared plus 8 squared equals C squared. So all I did was plug in the numbers. Okay? Now I'm going to simplify. I'm or make my problem a little bit easier. 6 squared equals what? What is it? 36. 8 squared is that really necessary? C squared. Now, I'm going to combine my terms. Okay, what can I combine? 36 and 64. What does that equal?
100.
Equals 100. So 100 equals C squared. But I don't want to know C squared, I want to know C. So how do I find? Divide by 2. Thank you. What's the opposite of x squared? The square root. So how do I find the opposite? Take the square root. So I would take the square root of c squared, and it would just become single c. And then I would take the square root of 100, and what does that equal? Thank you, good Truett. Why is it not 50? How would I have gotten 50? You divided by 2. Does this say to divide by 2? No, you have to take the square root. Now, most of these you'll have memorized, but also your 8th grade math, so you get to use your. So you want to make sure, second square root of 100. Does it equal 10? Absolutely. Okay? Is that hard? No. Now, sometimes they're not going to be nice, perfect, easy numbers, and when they're not, you leave it as a radical. Okay? So let's do one more together. Draw a right triangle. Draw a right triangle. The hypotenuse is C. I want you to label one of the legs 3 and one of the legs 5. If I wanted to find C, what's my first step? Write the formula. And people are going to ask, do I have to do it every time? What do you think I'm going to say? Yes. A squared plus B squared equals C squared. After I write the formula, check. What's next? Plug in what you know. Today, we're only working with the legs, so this will be nice and easy. I know that A is 3 squared. I know that B is
5 squared.
And I don't know what C is yet. Okay? Now I have to simplify. What is 3 squared? 9. What is 5 squared? I don't know C squared. Okay? Simplify. Combine like terms. 9 plus 25 is 36. Is it 36 or 34? 34, sorry. 34 equals C squared. Now I need to find C, so I do what? Take the square root. Well, I know that when I take the square root of C squared, it equals C. Now, is there a perfect square for 34? No, so you just leave your answer as a radical. So C equals the square root of 34.
Which is 5.
So it's called
If it's not a perfect square, then you just leave it as a square root. Yep. Okay? So this is Pythagorean Theorem. Does it seem very hard? No, it's not very hard. Okay?